So the other day at one of our Romeo luncheons, one of our distinguished members asked why a bad alkaline battery bounces. Several theories were presented. Friendly discussion resulted, so it was decided that we needed to do a little research and determine the answer to that controversy. We began with a group of good alkaline batteries and a group of bad alkaline batteries that have all failed in the device that they were used in. The question arose from the fact that if you drop a good alkaline battery, it has very little bounce to it. It's a little bit of bounce, but not much. If you drop a bad, used up alkaline battery, there's quite a bit of bounce to it. As opposed to a good one with very little bounce, and a bad one. Why is that? The two theories presented was one was outgassing from the electrolyte, causing an increase in containment pressure, causing an increase in spring constant, causing the extra bounce in the bad battery. And the other theory was it was the anti-bounce theory from the gel-like substance of the electrolyte. So we devised a couple of experiments to determine this answer. We have two tests that we're going to try and answer the outgassing theory. And the first test is done by dropping an object on the battery. Rather than dropping the battery, if in fact we have an increase in spring constant, we should get a difference between a good battery and a bad battery by dropping a weight on the battery, and one should bounce higher than the other. We have a test set up here. We're using a brass tube with a brass slug that we're going to drop through the tube, and the tube is used to keep the travel straight so it drops exactly on the battery. So we're going to drop the brass slug through a brass tube, and we're using brass to eliminate any magnetic effects, and we're dropping it on a bad battery. And we'll do it again. Okay, now we have a good fully charged battery, and we'll drop the slug. So there is not a convincing difference between dropping a weight on a good battery and a bad battery. To make certain that it is not the outgassing theory contributing to the bounce of a bad battery, we have drilled a small hole in the bottom of a bad battery, and we drilled a small hole in the top to relieve any gas pressure. So using the battery that has a small hole in both the top and the bottom, we'll drop it to see if it still has the bounce. And certainly it does. It has a considerable bounce. By the way, you can turn these upside down and they have the same effect. Now we'll investigate the anti-bounce theory. For those that don't happen to be familiar with the anti-bounce mechanism, if you take a normal hammer, pound it on a surface, it'll bounce. An anti-bounce hammer has a cylinder inside that in this case is filled with buckshot on both sides, and as you raise up the hammer and move it downward, the buckshot lags behind the motion of the hammer, and when the hammer hits the base, the buckshot catches up with it, and when it starts to bounce back up, the buckshot pushes it back down and looks something like this. So that's the anti-bounce effect. So it's time to do a little surgery on these batteries and determine what's going on inside the battery. On our left are a couple of good alkaline batteries, an Energizer and a Rayovac, and we've sawed them in two. They were a little difficult to saw in two. We'll take a closer look here. And the first thing you notice is they're a bit shiny. There was quite a bit of electrolyte squished out in the sawing process. As we work around the electrolyte paste, it's rather mushy, wet, and fluid-like. And here's the Rayovac, same kind of thing, rather wet and mushy and fluid-like. Now we're looking at the inside of an extinguished battery that's been used up, no longer functions, and you'll notice it's quite hard and firm inside. The liquid-like appearance has gone away. So I think we have our answer here. The good battery that exhibits little to no bounce is a result of the anti-bounce mechanism going on inside. On the other hand, the bad battery that bounces well has a very firm center, is non-liquid-like. So we're quite comfortable concluding that a good battery does not bounce much because of the anti-bounce effect from the electrolyte, as opposed to a bad battery bouncing quite a bit from the stiffness of the electrolyte. For this video, we've just showed one example. We have run a series of tests, but to keep the video short, we've just showed one example. And I should mention that a battery that is partially used up will bounce. Even though it may have a little bit of life left in it, we noticed in one of our cameras where the battery was exhausted when not run the camera, when put into a small flashlight, it powered the flashlight for a short period of time.